Okay, so still on our lecture series on motion graphs, here we're going to look at this question. A train starts from rest and accelerates uniformly at a rate of 2 meters per second square until it attains a maximum velocity in 20 seconds. It maintains this velocity for 60 seconds and then retards uniformly to rest after a further 20 seconds. A. Draw a graph of the motion. B. Use the graph to determine 1. The maximum velocity reached, 2. The retardation, and 3. The distance covered. So the first thing I would want to do here is to draw the velocity time graph for this motion. So first of all, I will draw my vertical axis and I will draw my horizontal axis, right? So my vertical axis in a velocity time graph represents my what? My velocity, which is measured in meters per second, while my horizontal axis represents time, which is measured in what? In seconds, right? So this is very important. So the question is, a train starts from rest. So this is the resting position. It starts from rest and accelerates uniformly at a rate of 2 meters per second. So the acceleration, the uniform acceleration is what? At a rate of what? 2 meters per second, right? 2 meters per second square. So this is the acceleration, right? 2 meters per second square, right? It accelerates uniformly at a rate of 2 meters per second square until it attains a maximum velocity in 20 seconds. So the maximum velocity is the height that is reached, right, in 20 seconds. So it accelerated for what? 20 seconds. It accelerated until it attains a maximum velocity into what? 20 seconds. So the time that was taken to attain, for it to accelerate uniformly and attain that maximum velocity is what? Is 20 seconds. 20 seconds, right? It maintains this velocity for 60 seconds. So that maximum velocity that is reached, it maintains this velocity for what? 60 seconds. So it maintains that same velocity for 60 what? Seconds. So that velocity was maintained. That's uniform velocity, right? It was maintained for what? 60 seconds. And then retards uniformly to rest after further 20 seconds. So it retards uniformly to rest. So that means it underwent what? It underwent retardation, right? For a further what? 20 seconds. So the time that was taken was what? 20 seconds. The first question is to draw a graph of the motion. This is just a graph of the motion, right? So we've answered A here. Then B, for B, we are asked to use the graph to determine the maximum velocity reached. So for I, we're looking for the maximum velocity that is reached. So the body underwent what? Uniform acceleration. It accelerated uniformly at a rate of 2 meters per second square until it attained the maximum velocity in 20 seconds, right? So we have that the acceleration is equal to 2 meters per second square, and the time taken is what? T is what? 20 seconds, and we're looking for what? The velocity. So we should know that acceleration is equal to what? Velocity all over what? Time. So since we're looking for velocity, we can cross multiply, right? So velocity will be equal to what? V times 1 will give us V. A times t will give us what? At. So velocity is equal to what? Acceleration times time. So my velocity will be equal to, acceleration is what? 2 meters per second square times the time is what? 20 seconds. So 2 times 20 will give me what? 40 meters per second, right? So this is the maximum velocity that is reached. So from here to here is what? 40 meters per second. This is the maximum velocity that is reached. Then two, we have to look for the retardation. Retardation. And what is retardation? Retardation is negative acceleration, right? That's from here, this slope is what we're looking for. From here to here, right? So So how do we look for our retardation? So you should know that acceleration is equal to what? Is equal to final velocity minus initial velocity over what? The time taken, right? So acceleration will be equal to, what is my final velocity? My final velocity is, because the body is retarding, right? Well, we have to look for the retardation. So this is a velocity, this will be my initial velocity, and this will be my final velocity at this point. So final velocity is 0, right? Here is 0, here is 0 meters per second, right? So my final velocity, because the body is traveling from here down to this point, right? So the final velocity, which is here, is what? If we trace it here, is 0 what? 0 meters per second. So that would be 0 minus my initial velocity was what? 40 meters, right? 40 meters per second. So that will be minus 40 meters per second divided by what? The time taken to decelerate. The time that was taken to decelerate, to retardate, is what? 20 seconds, right? So that will be divided by 20. So acceleration will be equal to 0 minus 40 will give us what? Minus 40 divided by what? 20. So minus 40 divided by 20, acceleration will be equal to what? Minus 2, right? Meters per second square. So this is our retardation, which is negative what? Acceleration, right? Then the next thing that we have to look for is the distance covered. So from what I've said before, that the distance covered in a velocity time graph is equivalent to the shape of this motion graph, right? So in this motion graph, we have a triangle, a right angle triangle, we have a rectangle, and we have another right angle triangle, right? So this is the right angle triangle. This is a right angle triangle. So the distance covered, so this will be our 3. The distance covered, so the distance covered will be equal to the area of the shape of the graph, right? The distance covered will be equal to the area of the shape of the graph. So here we have a right angle triangle, here we have a rectangle, and here we have another right angled triangle, right? So what is the area of a triangle? So for this first one, the area of a triangle is what? Half base times what? Height. Then plus the area of this rectangle plus area of rectangle, which is what? Length times breadth, plus the area of this right angle triangle, which is half base times what? Height. So this will be equal to half. What is the base? The base is what? 20, right? So that will be 20 times the height is what? 40, right? 40 meters per second square. That's our velocity, right? So that's times 40 plus the length of this rectangle is from here to here, right? Which is 60. From here to here, 60 seconds times what? The breadth, which is from here to here, and that is 40, right? So times 40 plus I have, what is from here to here? From here to here is what? Which is your height. From here to here is your height, which is 40. Then your base is what? 20, which is from here to here. So that's half base times height is times 20, which is this 20, times your height, which is from here to here, and that is 40, right? Times 40. So this will be equal to 1/2 times 20 will give us 10, right? 10 times 40 will give us 400, plus 60 times 40 will give us 2400, plus 1/2 times 20 will give us 10, times 40 will give us 400, right? So that will be equal to 400 plus 2400 plus 400 will give us 3200 meters. So this is the distance. This is the total distance that is traveled, right? This is the distance from here to here to here down to here. It is 3,200 meters, right? So the distance that is traveled, the very important thing that you should know here is that the distance that is traveled is equal to the area of the shape of the graph. The area of the shape of the graph, right? And we have three shapes here. We have a right angle triangle, we have a rectangle, and a right angle triangle. So the area of these various shapes will give you the total distance that is covered.